Heather, maybe sit down and relax as we find out a little bit more about a beautiful little girl named Ebony, about a mouse and a team of neuroscientists, and how they're all on the quest to help Ebony. In fact, Ebony is the daughter of Tim Bohm, and she has epilepsy, a rare form of genetic epilepsy. But she could be turning things around, not just for herself, but for others in the world. Tim, good afternoon to you.
Hi, Sonia. How are you going?
Yeah, good to talk with you. Tim, how old's Ebony nowadays?
She'll be 5 in December, so...
She'll be 5. When did you first notice and realise that she had some very serious seizures going on?
She had her first seizure when she was about 12 weeks old.
3 months old, wow.
Yep.
And what happened when you took her to the doctor with that? What were you told?
So actually I was away on a work trip overseas, so my wife unfortunately had to deal with Ebony's first seizure, so she had to call an ambulance and we got airlifted to the Women's and Children's in Olo, and yeah, it was a bit of an investigation from that point on to find out what she had.
Many months, I think more than a year later, you ended up at the Florey Institute. And what were you told there as you were looking for answers?
Just that we sort of got on to Chris, and he said that he would do what he could and maybe look into see what was causing Ebony's epilepsy.
After more than a year of perhaps looking for some of those answers, what was that like to have someone who said, yeah, we're going to sit down and try to find the answers to this properly?
Definitely gave us some hope that, you know, here's some smart people that might be able to solve the problem. So, yeah, definitely a lot of hope that maybe one day, they might find something that could help her.
Tim, what's Ebony's life like now as a nearly 5-year-old? What sort of what impact does epilepsy have on her life?
So other than suffering from seizures from time to time, it also causes some disabilities and her ability to learn. But she's quite a happy little girl, and she can say a few words, so she likes saying hello to people, and she likes books and having books read to her. She can walk with a walking frame, and she's just started to take a few little independent steps, but we've seen when she has seizures that can regress quite quickly.
And so are those seizures impacting on her ability to learn, to walk, and all of those things you're describing, on those disabilities that you're talking about? Is that as a result of the seizures, or is that in addition to?
I think it's in addition to, so it's part of her underlying condition that causes the seizures. So that's where her seizures are somewhat managed with medication, but that's kind of band-aiding the condition. It would be great to try and sort of fix the root cause of what's causing her seizures and her disabilities.
Well, Tim, you mentioned Chris, Professor Chris Reid. He is from the Florey Institute of Neuroscience and Mental Health. In fact, he's the head of the Neurophysiology of Excitable Networks Laboratory. My God, that sounds like a wonderful title, Professor.
Yes, sorry about that.
That's fantastic. I haven't heard anything like that before. Professor, we've heard about it from a father's point of view. Can you explain your interest in Ebony and what you think you can actually perhaps help with in terms of her condition?
Yeah, sure. You can hear me?
Yes,
right?
We can indeed.
That's good. So I am a bench scientist. I love solving problems, and you know, a big part of my life has been trying to understand the genetics of epilepsy. That's been a 15-year journey, and you know, the way that we've progressed, the fact that we even know that Ebony's, you know, the genetic cause of Ebony's epilepsy is based on many people's works, including my own, over many years. And yeah, a big part of wanting to help is to try and, well, there's two aspects to it. The first is that need to understand things, and that's a scientist's want in life, I guess. And then there's the second component, which Tim was really tapped into, at least from a personal perspective, and that's to try and help a little girl, Ebony. And, I think the two marry really well together. And the hope is that we can take our scientific knowledge by introducing the genetic information that we know from Ebony into mouse models, which is what we've done. And through that process, we've actually, I think, come quite a long way in actually understanding what's causing Ebony's epilepsy. And because of that, we can now start to think of what we call targeted therapies, where we actually target that deficit, the actual cause. And Tim mentioned the two components, there's multiple components, but two major components of the disease, which include the seizures, and then the second component, which is also probably often more of a concern, which is the developmental delays. And the hope is that if we can fix that cellular deficit, we can fix both those problems, whereas at the present time, really the drugs that Ebony's on are just dealing with that seizure, and in fact maybe even possibly making the developmental aspects worse.
So if you can target those drugs more specifically, she may not have some of those other things we're talking about.
That's the hope. I mean, I think we've got to be clear here that Ebony has had 5 years of the variant, and we're not saying that we're going to potentially fix everything. What we are saying is that if we understand the disease better, we're in a much better position to make Ebony's life as best as we possibly can.
Professor Reid, you mentioned a mouse and how you, if I've got this correctly, replicate Ebony's genetic condition in the mouse. How do you do that? How have you broken that down?
So, Ebony was unwell. She had a genetic test, and that genetic test. So, Ebony was unwell. She had a genetic test, and that genetic test found a genetic variant or a mutation is probably something that people are more attuned to. And what that means is that basically the genetic code for a protein, which is called HN1, had one small spelling mistake, essentially. So the only difference between Ebony and the rest of us in that channel is that one little spelling mistake. We can put that spelling mistake into a mouse. And a mouse is a mouse. We have to be clear about that. But what's remarkable really is that by putting that spelling mistake into the mouse recapitulated very many of the sort of phenotypes that we see in Ebony, including the seizures and the developmental delays. So, it's an exciting time for science and the genetics of disease for our ability to be able to do that now.
And so does that mean then that you can try, because I've met a few people who either have children or themselves have epilepsy, and it's a bit of a process to sort out which medications may be applicable to their individual circumstances, and sometimes some of them don't ever get great results. So are you able to test out the medication on the mouse before you test it out on Ebony?
So, I mean, it's not a perfect science. A mouse is a mouse, but that's exactly what we have done. So there's two ways that you can use this mouse. One is to really understand what's happening at the cellular and the network level within the brain. And the second is really like a black box. The mouse has a seizure phenotype that we can look at, and then we can see whether drugs help or don't help. And as I said, it's not an exact science just yet, but what we've noticed is that a subset of drugs, what we call sodium channel blocker drugs, are definitely not a good thing in the mouse. And in fact, when Ebony has tried those drugs, she has got worse. So it definitely, I think, trying these things in the mouse and then ultimately getting that stuff out in the published world means the next patient that comes along that has a variant in the gene that Ebony has her variant in will not have to go through that trial and error process that Ebony went through.
You're listening to ABC Radio Adelaide, South Australian Broken Hill. Professor Chris Reid is my guest from the Florey Institute of Neuroscience and Mental Health. We're talking about epilepsy, and in particular the kind of genetic epilepsy that nearly 5-year-old Ebony has, and she's a Tanunda girl. Professor, this is world first research. Does that mean that this is the first time you're specifically trialling this with an individual in this way?
The approach is not original. There are, the approach that we're using has been used for other genetic variants in other genes. The approach itself is actually very powerful and is proving to be useful, not just in Ebony's case, but in a range of other developmental epileptic encephalopathies in particular. But it is the first time that a published mouse has been on the HN1 variant, which is the specific variant that Ebony has.
Is this, how viable is this to do it with the many different types of epilepsy? And there seems to be many out there.
Yeah, so it's a very good question. We're not going to be able to make an Ebony mouse for every child that has an HN1 variant. That's just not feasible, clearly. But as I've sort of hinted already, we've done something that's forever now. It's in the published literature. It's there, and that means that variants of patients with HN1 variants are going to come along over the next decade, 2 decades, 3 decades that will have very similar phenotypes to sorry, I'm sort of slipping into science to speak, but very similar sort of disease type to Ebony. And that's a piece of information that we won't need to make the mouse again. That'll be information for those patients moving forward. And then there's also broad stroke benefits that if we can find things that work in the Ebony mouse, they may be more broadly applicable to a range of different epilepsies as well. So it's not just about Ebony.
And so how long does this continue for?
I guess until we have a solution to the majority of the developmental encephalopathies. There's going to be a variety of different approaches that are taken. We call it a precision medicine types approaches. And some of that can be what we've already talked about, which is just knowing which drugs are best for that particular epilepsy type. And once that's set in stone, that's things that can move forward. The second is to directly target a new drug, basically, against the actual deficit that you've got. And then there's a third approach, which is genetic approaches, which are starting to gain quite a lot of traction, where you actually target the actual genetic deficit itself and use a gene targeting approach to either change that genetic makeup or do it. And then that may be more applicable across the board as we move forward.
Are you learning or likely to learn greater things about epilepsy, or only the things about Ebony's form of genetic epilepsy?
No, so one of the interesting things that we've noticed with the Ebony mouse is that it has a drug profile which is very similar to quite a big broad spectrum of epilepsies called genetic generalized epilepsies. And in that context, the sodium channel blockers that I talked about before often make things worse. So we can use this mouse model to try and understand at a higher sort of network level why these drugs make things worse. And if we can do that, then that will have implications well and truly beyond just treating Ebony and even patients with HN1 variants alone.
Well, Professor, it sounds like fantastic work you're doing there, particularly, well, for all people, but particularly for little Ebony from Tanunda. Thank you very much for your time. Professor Chris Reid is head of the Neurophysiology of Excitable Networks Laboratory at the Florey Institute of Neuroscience and Mental Health. Before we let him go, Tim Boehm is Ebony's dad. You must be very grateful for the amount of effort going into this, Tim.
Oh, yeah, extremely grateful. Like I said before, it gives us a lot of hope. So, yeah.
Yeah, well, look, our
exciting time.
Yeah, let's hope that Ebony eventually is seizure-free and can go on to develop as much as she can without those seizures.
For us.
Yeah, that would be an amazing thing, I'm sure. Might just mention too, there is a GoFundMe page that's been created for Ebony called Help Ebony Be Seizure-Free. Obviously, that is still... that's still a goal, that we're not there yet. Ebony, wishing the best for Ebony and yourself, Tim. Thanks so much for joining us today.
Thank you very much.
Tim Boehm.